All right. What's an identity? You know, what's an identity? Something identifiable. It's an equation that is true for all values of the variable. For all thetas, it's always going to be true, right? The sine of theta always equals 1 over the cosecant of theta. Do y'all agree with that? Doesn't matter what theta is, that will work. A conditional equation, what we're going to be doing today, is an equation that may be true for certain values of a variable, but false for others. So the sine of theta equals 1/2 is not true for every theta. Only some thetas have a sine of 1/2. What theta has a sine of 1/2? We're going to talk about that in just a second. An inconsistent equation has no solution or is extraneous. Do you remember learning that word in Algebra 2? So the sine of theta equals 2. Is that possible? No. Why not? Because if I put 2 over 1, then your y is bigger than your r. Can your y be bigger than your r value? So that's extraneous. That's no solution. Does that make sense? Okay. What we are doing today is we are going to be solving equations. So if I go to page 17, I am going to ask you to do number 1. I'm going to try to get through 7 of these today. We'll see how far we get. The cosine of theta equals 1/2. How do I, what's my variable here? Theta. How do I get theta by itself? Ooh. Inverse cosine. And what you do to one side, you do to the other. Those cancel, and theta equals inverse cosine of 1/2. Where is theta 1/2? Sorry. Where is cosine 1/2? Pi over 3 works. Where else? Five pi over 3. Where else? Do y'all agree cosine's even? Negative pi over 3. And negative 5 pi over 3. And I could actually keep going around my circle. So I could say 7 pi over 3. And I could just keep going. Do y'all agree? I gave you, last unit, a green circle. And that restricted you to the principal inverse cosine function. We are not going to use that green circle anymore. We are going to go back to the pink circle. So, for example 2, right next to this, it is going, if I ask you for the cosine of theta equals 1/2, but I'm going to tell you this time, hey, your theta is between 0 and 2 pi. If I give you an interval of your unit circle, we're going to do the same thing. Inverse cosine to both sides. What is the inverse cosine of 1/2 on this interval right here? What would theta equal? Pi over 3 and 5 pi over 3 only. Do you see the difference between these two? One of them has no interval. One of them I'm giving you an interval. I'm almost always going to give you this interval right here. There may be some times where you need to pay attention. Maybe you'll only go to pi. Maybe you'll go to 4 pi and have to do 2. I mean, 99 times out of 100, this is the interval I'm giving you. So since we're solving, we need what? Solution sets. So S equals pi over 3. 5 pi over 3 would be my answer. The answer here, I'm going to have you write down. You do not have to have this memorized in any way. Is going to be theta such that theta equals pi over 3 plus 2k, and theta equals 5 pi over 3 plus 2k, where k is a variable that is an integer. Let me say this again. You don't have to memorize this. You're not going to be expected to write it like this. I just need you to see the difference in answers without intervals. Do y'all remember in the graphing unit I used n? You could use n right here. It's just a variable. Okay? K, n, you could put p, you could put a, you could put x. It's just a variable. Again, if you're like, what? Don't worry about it. Do you get this? Then you're good. Can I move on? All right, example 3. What about the 2 sine theta plus square root of 3 equals 0? What is theta here? How do I find it? Solve the equation. What am I going to do? Move square root of 3. And then divide by 2. And then say it again. Inverse sine. What quadrants is your answer going to be in? Quadrant. It's a negative sign. Where's sign negative? Quadrant 3 and quadrant 4. So, my S is going to equal, where's sine negative square root of 3 over 2? Where's your Y, negative square root of 3 over 2? Five pi over 3 and 4 pi over 3. And if you're like, yep, nope, you need to brain dump that unit circle every day. Takes you 4 minutes, one time a day. Brain dump it every day for the next week. Add that to your schedule. Do it once at lunch. Time each other. See who can do it faster and correct. Okay? You will get a blank unit circle on this test. Okay? But it'll be blank. You got to fill it out. Are we okay? Can I answer any questions about what we did, how we did? Oh, I made a mistake. No, I was just supposed to give you an interval. Ask me. Honestly, I'm really bad at remembering to write it down. Your homework will have it at the very top. All of these are on this interval. Alright, here's example 4. 2 tan of theta minus the square root of 3 equals tan of theta. On the interval, 0 is less than or equal to theta is less than 2 pi. So between 0 and 2 pi. What is my first step? I'm going to move the square root of 3 to the right side and subtract tan so I can make the tans come together. Two tan of theta minus tan of theta, you don't need a computer out right now, you need to be writing this down, is tan of theta. 1. You could put 1 tan of theta or just tan of theta. And that's just going to leave me equals the square root of 3. Does everybody see how I went from here to here? Move that to the other side, move that to the other side. What do I do? And I'm okay with you combining your steps like that. If you do not show this step right here, you will get points off. What quadrant is your tangent positive? Quadrant what? 1 and 3. So our answer should be in quadrant 1 and 3. Where is tangent the square root of 3? Everything we're doing up until this point right here is algebra. At this point right here, then you need to know your unit circle. Alright? Again, brain dump it once a day, you'll be solid by the test. The test is next Friday. Halloween, yep, it's a Halloween test. Am I going trick-or-treating? I think I'm taking my daughter, yes. Yep. I gotta decide because we bought stuff to hand out. So do I just put it at the door? Yeah, right. Well, I bought like a pack of Oreos, a pack of Rice Krispie treats. I didn't buy candy. And a pack of gummies. No. I'm going to go to the Fall Frolic in Jersey Village. Alright, what do I do here? Divide by 4. So the sine squared of theta is 1/4. Square root. So the sine of theta is what? 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 Plus or minus 1/2. Don't forget if you square root, you get plus or minus. You'll automatically get half the points off because you're going to miss half your answers. Square rooting is plus or minus. And then I'm going to inverse sine both sides. So your theta is the inverse sine of plus or minus 1/2. Ooh, thank you. Interval, my bad, thank you. Good questions though. It's important to ask that. Interval is 0 to 2 pi. What quadrants is sine going to be plus or minus in 1/2? What quadrants is sine positive and negative? All quadrants. So how many answers should I have here? You should have 4 answers. Where is sine 1/2 and negative 1/2? all the pi over 6's. And 11 pi over 6. Questions? We're okay? Good.
What if you don't do like in the step you don't do the positive negative, but you get the right answer?
So how would you get the right answer if it's not positive? Then this wouldn't be equivalent to that.
Like we didn't write the positive negative, but we just did it.
Then that would not be equivalent to that. You get points off. So you would get points off for square rooting it wrong, and then you'd get points off for making this equivalent to that. All right. Can I change it? Are we okay? All right. What if I did... I'm moving to the back because I don't know where I am. What if I did example 6? Yes. No. Because I'm teaching. You're fine. You're a big boy. Okay, I'm going to add 8. Are we a little bit nervous about this one? Why? Why does this one make us nervous? It makes me nervous looking at it right away. Because it's cosecant. We'll get there. What am I going to do?
Divide by 5.
Divide by 5. What is 10 divided by 5? 2. Do not do the inverse. What can you do instead?
1 over sine.
And I don't even need you to do that. You can, but just convert it to sine. What is sine of theta going to equal? If you take the reciprocal, take the reciprocal of both sides. And now doesn't this look like earlier? Now isn't this a lot prettier?
Yes.
So right here, if you want to like make a note right here, just write take reciprocal of both sides. Now I can inverse, and my theta equals the inverse sine of 1/2. What quadrants is your sine positive? Where is sine 1/2? And again, if you're sitting here like, okay, I get everything, but from here to here is where I'm lost, brain dump your unit circle. Use your unit circle.
Breakfast, lunch, dinner. Wake up, go to sleep, shower.
Before 6th period, after 6th period.
That's 8 times.
Oh. Don't do it when you shower. That's weird.
No, like just take it to the wall.
Oh, okay. Sure. All right. Do I have any questions so far? Okay. Is this the hardest it gets? No. On Friday we were doing solving harder trig equations. And honestly, so let me say, it's not that the trig equation, it's that the algebra is harder, not that the trig is harder. Okay, I want you to start example 7. Example 7 is a special case. Example 7 is a special case. Man, we've done a lot of sines of 1/2. Should I change it? Keep it that? Example 7 is special. How is this one different?
Double identity.
Okay, it has the double angle. You are not using an identity when you are solving. Let me start off by saying that. You do not need to use the identity. But I'm still going to do the same method. What would we naturally do first here? Inverse. I cannot divide by 2 because it's inside my parentheses. I'm going to have to inverse first. Oh, wait. Interval. Sorry. You were super lost, I know. Okay, interval is going to be the regular interval. So 2 theta is going to equal the inverse sine of 1/2. What is my inverse sine of 1/2? We just did this the last time. Do y'all agree that is pi over 6? Okay. Do you see how this is 2 theta? Everybody look up. Shh. Look up. Edwin, get off your computer. Everybody look up. Do you see how this is 2 theta? Do you see how this is theta?
Yes.
These are not the same. So what am I going to need to do to have the same interval? What am I going to need to do to this? Multiply it by 2 so I can get 2 theta. But if I do that, what am I going to have to do? Multiply all of them by 2, which is going to change my interval to 4 pi. Which means pi over 6 and 5 pi over 6 are not my only answers. What else is an answer? It's going to go around the circle once and again. So what am I going to find the second time around the circle? No. How are you getting 13 pi over 6? You add 2 pi. What's this?
Oh my goodness.
Going to be
17
pi over 6. So if you want to make a note, we added 2 pi. Or what's 2 pi over 6 going to be? Not 2 pi over 6, but what's 2 pi when you're dividing by 6? 12 pi over 6.
What was it? Coterminal angles?
Coterminal angles, correct. So 2 theta equals pi over 6, 5 pi over 6, 13 pi over 6, and 17 pi over 6. Does that make sense why we got so many? Because I had to double my interval because my theta is doubled. Question. Is theta by itself? How do we get theta by itself? And we are going to have to divide all of these by 2. What is my answer going to be? Pi over, no, divided by 2. 12. 5 pi over, 13 pi over, and 17 pi over. Now do you see why I starred this one?
Yeah. Wait, this part is long? Is this the harder?
No, that's not the harder. That's the easier. Your harder one's not till Friday. Alright, that is, yeah, time is running out. That's all we're doing today. Tomorrow we're going to be doing what if it's not a special angle on the unit circle. How do we find theta? And then we will be doing harder trig equations, starting with quadratics. Yay!